Hi, in this video you will learn SF6 circuit breaker. In SF6 circuit breaker, sulfur hexafluoride gas is used as arc quenching medium. The composition of one sulfur atom and 6 fluorine atoms forms SF6 gas. SF6 gas is known for its high dielectric strength and excellent arc quenching properties, making it valuable in electrical equipment like circuit breakers and gas insulated substations. The first industrial application of SF6 gas for current interruption was made in 1953, where 15 kV to 161 kV load switches were developed with a breaking capacity of 600 ampere. The first high voltage SF6 circuit breaker built in 1956 by Westinghouse, and it could interrupt 5 kiloampere of current under 115 kilovolt voltage. In 1957, the puffer type technique was introduced for SF6 circuit breakers, where the relative movement of a piston and a cylinder linked to the moving part of the breaker contact, which is used to generate the pressure necessary to blast the arc via a nozzle. Nozzle is made of insulating material. In this technique, the pressure rise is obtained mainly by gas compression. Now, we will see some important properties of SF6 gas. SF6 gas is non-flammable. That means it is stable up to 500 degrees centigrade and it is highly resistant to reaction with water and acids. Due to these properties, making SF6 gas ideal for use in electrical equipment. Second property is, due to its ability to absorb free electrons, SF6 gas has excellent dielectric strength, which is about 2.5 times that of air. SF6 gas is non-poisonous and therefore not harmful to health. Other properties of SF6 gas are, it is colorless or transparent, and SF6 gas don't have any smell. Due to all these benefits, SF6 circuit breakers are preferred in wide voltage range from 36 kV to 765 kV. Now we will discuss puffer type SF6 circuit breaker. Puffer type SF6 circuit breaker is also called as single pressure type circuit breaker. In this type of circuit breaker, two contacts are made available like any other type of circuit breakers. One is fixed contact and other is moving contact. A moving cylinder is linked with the moving contact so that at the time of opening of contact, moving cylinder will also move along with the moving contact. Nozzle is made available on the piston of the moving cylinder to allow the SF6 gas to flow. A fixed member is connected at the back side of moving cylinder. A non-compressed SF6 gas is placed between moving cylinder and fixed member. Now we will see the working operation of SF6 circuit breaker. At the time of normal operating condition, fixed contact and moving contacts are closed. When fault occurs, moving contact will move backward along with moving cylinder. As moving cylinder moves, SF6 gas present between moving cylinder and fixed member will get compressed. Arc is formed between fixed contact and moving contact. Compressed SF6 gas is allowed to pass onto the arc through nozzle, and due to high dielectric strength of SF6 gas, arc interrupted. Second type of SF6 circuit breaker is non-puffer type. It has a moving chamber and a fixed chamber. The non-puffer type SF6 circuit breaker has an interrupter part. The arc quenching process is performed in this part only. It consists of two contacts, the fixed contact and the moving contact. The fixed contact has arc horns connected with it. Arc horns are used to protect the switching components of the breaker from damage caused by flashover. The moving contact has rectangular gas outlets. The gas, after the process of arc extinction, moves out from these rectangular holes. An insulated rod is connected to the moving chamber for its operation. The main arcing process is done in arc chamber. The valve is synchronized with the moving contact of the circuit breaker. It means as soon as the moving contact separates from the fixed contact during any fault, then the valve of SF6 gas tank will automatically open and flow of gas will inlet to the arc chamber. Initially, the contacts are in closed position surrounded by the sulfur hexafluoride gas. When there is a fault in the system, then the moving contact begins to separate from the fixed contact. According to the arc interruption theory, the surrounding medium will ionize and arc will be stuck between the contact. To understand the arc interruption theory in detail, watch my video how electric arc produced and how to interrupt the arc. Video link is available in the description box. The valve connected with the SF6 gas tank will open and the gas will enter in the arcing chamber. Now SF6 gas will flow through the arc and it will quench the arc in very short time. After the extinction of arc and interruption of current, the gas moves out from the gas outlets and it will get reconditioned for further use. Apart from all the benefits of SF6 gas, there are certain disadvantages. Like SF6 gas itself is expensive and the specialized equipment needed to handle it. And also the breaker's complex design contribute to a higher initial cost compared to other types of circuit breakers. SF6 influences greenhouse gas with a high global warming potential. If it releases into the atmosphere, it will contribute significantly to climate change. During arcing, SF6 can decompose into toxic substances like sulfur dioxide, which can irritate the respiratory system and skin. SF6 gas can leak from the breaker, potentially creating an uncomfortable environment due to its density. Handling and maintenance of SF6 circuit breaker requires specialized training to prevent leaks and ensure safety. SF6 gas needs to be reconditioned after each operation to remove impurities and maintain its insulating properties. Due to all these disadvantages, in future, vacuum circuit breaker can capture the high voltage market. This is about the SF6 circuit breaker. If you found this video useful, don't forget to like, comment, share and subscribe for more videos like this. Till time, keep learning, keep growing. Thank you.